So how exactly is a weather forecast made? How do these meteorologists predict the weather, sometimes as far as 10 days out in advance? That's something that I want to talk to you about today. So before, there was all those old-time methods used to forecast the weather, right? Before there was even satellites, you could just say, well, the weather now is going to be the same an hour later, just slightly different. There was also methods used in predicting animal behavior and plant behavior that was used to tell the weather, as well as changes in pressure, changes in wind, changes in cloud cover. Today we use modern day weather models, and there's three models that we use in particular for forecasting the weather in the United States. We use the American model for one, otherwise known as the GFS, the Global Forecasting System. There's also the European model too, the ECMWF. And then there's also the Canadian model that's used from time to time, but it does have a cold bias with it, so that's something that we don't use quite as often. Those are long-range global weather models, and then there's also short-range models that are more mesoscale, they get more in-depth, such as the North American model, the NAM, and the High-Resolution Rapid Refresh, the HRRR, HRRR, or the HRR as some folks call it. So for example, let's say that we want to find the high temperature for next Monday, and right now it's Thursday, so that's still about 4 days out. We would use long-range weather models to look at that, or medium-range weather models. So we'd use all three, the American, the European, and also the Canadian model. I've already got the data for next Monday's high temperature. The European shows 77, the American model shows 75, and the Canadian model is showing 69 degrees. So what we do is, just from basic algebra, we learn to find the average of all three of those values. So you add all those numbers up, you get 221, and there were three models we looked at, so we divide that by 3, and we get the average. That's 73.6, and that rounds up to about 74. So that's going to be the average high temperature that the weather models are showing for next Monday. However, you have to be cautious though, because you got to know when some models are going to show biases, and you also have to know some models might show a storm coming in that might influence other weather patterns. And so that's something that you're going to have to learn to recognize some of those patterns in the weather models. Now, if we're trying to forecast the weather within 48 hours or even 72 hours, we would use short-range weather models like I mentioned before, and the HRRR model is a very good one to use, although lately in severe weather forecasting for the Carolinas, it hasn't done so well. It hasn't picked up on convection, which is a fancy word for thunderstorms, and it plays every hour, it runs every hour, and it shows you the forecast for the next 18 hours. Now, every 6 hours, this model will run for 48 hours. That's a lot of numbers to crunch there, but this model is very useful in forecasting hour-by-hour weather predictions. The HRRR model also recently came out with a 15-minute increment model, which is just like it sounds. We'll show you the weather every 15 minutes, so we can look at what the temperature will be like at 12 o'clock, 12:15, 12:30, etc. But that model is so powerful that it only goes out, say, 12 to 18 hours, so that's something that we get every 6 hours. It runs in Zulu time, so 0Z, 06Z, 12Z, and 18Z. Well, boom! Now it's Friday, and we actually have the chance for severe thunderstorms today in the Carolinas. We can look at that here on the weather models too. They have all sorts of parameters. They sound fancy, scientific, things like CAPE, CIN, significant tornado parameter, all that good stuff we can look at, especially in the short-range weather models. These weather models are made using ensembles. That's where the model is run several times each time it is ran. Some go up to 50 different runs at one time, and they all have different scenarios, different starting locations. They change different stuff. It's kind of like a what-if scenario, and then all of that gets averaged into the operational run that you see often posted on the internet. We use ensemble members a lot when forecasting hurricanes or other type of pressure systems, as it shows various different tracks the storm could take, helping us get a better idea of the exact path a hurricane or a tropical system would go. I personally like to write down all this information that I see on the weather models using this iPad Pro. It's the latest version, and also with the Apple Pencil Pro. It's really good just to write it all down on an iPad, and then I can look back on it later. Now, we also have global models, not just the three that I mentioned, but we have the Japanese model, JMA, UK Met model for the United Kingdom, and even models for Germany like ICON, ICON. So these models are used in the United States as well. They're just not used as much as the typical GFS, European, and the Canadian models. These models tend to work best in the area that they are set to forecast the weather for. Now we also have something that's called the NDFD, the National Digital Forecast Database, and that is where the National Weather Service, all of their 100 plus offices come together and they put together their own forecast several times a day, and that is averaged here into a computer. Notice this is all about averaging here, and we can look at this in the form of maps, in the form of text, however you'd like it. That is the National Digital Forecast Database. Alongside that, there's also the National Blend of Models, which, just like the name implies, it's blending all the models together. You do have to know if there is one model that's slightly off or greatly off from the rest of them, that's going to change the average by quite a bit. So you have to know when to analyze that. But nonetheless, the National Blend of Models is a good way to just look at the average of all those models. If you don't want to add up all the numbers and then divide or do all the math, you can just look at the National Blend. Now, the website that I use to look at all these models is called WeatherBell. It's a very nice website. It does cost you $30 a month though to use it, or you could use their yearly subscription. There are free websites you can use to look at some of these models. You don't get all of the parameters. One of the good ones is tropicaltidbits.com, and also the College of DuPage up in Illinois. They have websites too where you can look at the models for free. And there's other websites too that have paid subscriptions that allow you to go more in depth. Pivotal Weather is one of them. They do have some products out there for free as well. But WeatherBell, I would say, is the best website in my opinion. So how exactly do these weather models know what to predict? Well, first they get data from the National Weather Service. They typically launch a balloon every 6 to 12 hours depending on the office, and then they use current Mesonet data. They also use satellite information, as well as planes sometimes fly by and give weather information in the upper parts of the atmosphere. And then they use intense mathematical equations such as thermodynamic equations, Navier-Stokes, math equations you would typically learn in Calculus 3 or differential equations, or maybe even higher than that. And they run on these supercomputers. You can find them in the United States, Europe, the UK, and also Japan. And they run quadrillions of calculations per second. We're getting into petaflop territories here. And they do this back to back constantly. Once one model is done, they go straight on to doing it all over again with the newest weather data. So here's a really good example. We can look at this on WeatherBell, and this is the National Blend that we talked about earlier, and this is for Charleston, the Charleston International Airport. And it does show the graphs for the high and low temperatures for the next 10 days. Now this is going to change. It runs every 6 hours, so it does change quite a bit, but for the most part it tends to remain the same. And then we have all these other different models that we can look at over here, and a bunch of different products that we can look at too, such as Surface Summary. This is a really good one. This, it looks more technical than it should be, but this is just a graph. Here shows you the amount of rainfall we're expecting, so this is a good indicator of your rain chances. And then the blue line here is the cloud cover along with the humidity, and then we have our winds and temperatures up here. So that's a good way to look at the blend of all those weather models put together. And then we can also come up here to maps, and we can look at this in the form of maps too. So this is the European model, and we can look at the temperature run throughout the next 10 days. And it's even gone out to 14 days at some points, like the GFS model will do. Now it is worth noting that sometimes these models do go out to 14 hours, or 14 days I should say, that they're not always accurate that far out. In fact, some meteorologists tend to call it la la land when it goes out that far, days 10 to 14, because it just tends not to be that accurate. Everything that you see that happens in that time frame on the model, it tends to be completely different by the time it rolls around. Tropical Tidbits is another good one, especially if you're into hurricanes and tropical systems like me. That's actually my favorite type of weather to do forecasting for. And what's cool about this is we can go to specific hurricane models and we can actually track the hurricane hour by hour here. So it'll zoom in on the hurricane. So this is Alvin right now in the Eastern Pacific, and it'll show you the path that it thinks the storm is going to go every single hour, and it'll even zoom the map into that area, and we can look at the thermodynamics, the upper and lower dynamics too, cross sections. So this would be like if we slice the storm in half, what would we be looking at in terms of vertical velocity and anomalies. So this is pretty cool. Each website has their own pros and cons, but this is really good if you like looking at tropical systems. A lot of people don't know about the specific features that all these websites have to offer. And it's also worth noting on here that we do have climate models too from the CFS, and this shows us anomalies. So the red would be above average and the blue is below average. We can look at this for every week and even every month too. So this is actually going out to the middle of July. It's expecting the entire lower 48 to be above average. And same thing with the monthly forecast. This goes all the way out to January and February of 2026. This is a little bit more accurate because we can start to look at patterns for that time, but we can't look at exact details that far out. It's even hard to look for exact details more than 2 weeks out in advance. And of course, not only can we look at those weather models on a computer, we can also look at them here and bring them into nice looking graphics. They're usually a little bit more pixelated than this, especially when you look at the raw data, but the computer will summarize it and it'll soften it up a little bit so it looks a little bit nicer to the viewer and to the audience that's looking at it on the camera on the screen. And here in the graphics system, we can look at anything we want to, such as severe weather parameters, temperature, future radar, dew point, wind gusts, you name it. That's stuff that we can show right here on the maps in the graphics system. So there's the basic gist on how all these weather models that we show up here on the screen work. It's a really complicated process, something that we don't usually think about. And we're very lucky to have this because back in the day we didn't have these complicated weather models, and even in today's world in 2025, in the day and age of AI, we're starting to see these weather models get more and more advanced and starting to get more smart, starting to pick up on some of these localized microclimate patterns. And so we'll just have to wait and see just how good do these weather models get in the coming years with the advancement of technology.